In this video, we are going to learn about Eventhouse. That is one of the main data stores in Fabric. We're going to cover an introduction to this data store and then especially going to focus on Materialized Views and OneLake Availability that are important topics to understand with this data store. And also in the DP-700 exam. Stay tuned! Welcome to the video. My name is Alex and on this channel I cover Microsoft Fabric and Azure related topics. In this video we'll continue our DP-700 exam prep series and link to the entire playlist can be found in the description. This is the episode 15 in this DP-700 exam prep series and in this episode we will cover Eventhouse. That is the last data store that we have not yet covered properly. We have already written data to this data store when we covered event streams, but now we are going to dive way deeper into it. Like in every episode in this series, we will first start with the theory section, followed by demos/tutorials on Fabric, and then we end the episode with few questions related to topics covered in this episode, so that you can test your knowledge. But now, let's get started. Eventhouse is a data store that is optimized for real-time data and analytics. It is designed to handle large volumes of fast-moving data, like telemetry, clickstreams, and IoT events. Eventhouse is actually a logical grouping of KQL databases, so you can think of Eventhouse as a container or a folder of KQL databases, and each one of these KQL databases inside Eventhouse is optimized for fast event ingestion and high-speed analytics. This makes Eventhouse ideal for scenarios where you need to quickly collect and analyze streaming data. The primary way to query Eventhouse data is by using Custom Query Language or KQL. However, you can also use TSQL for some basic exploration tasks if needed, since typically people are more familiar with SQL than KQL. But to get most out of this data store, you really need to learn KQL, since everything is not supported using TSQL syntax. Another important feature is OneLake Availability. Eventhouse can be made available in OneLake, which means it can be accessed across the Fabric services like warehouses, lakehouses, and Power BI without using the KQL database engine in between. But we are going to come back to this feature in following slides, since this is an important feature in Eventhouse. Finally, Eventhouse supports flexible data ingestion from many different sources. You can ingest data from local files, OneLake storage, real-time event streams, Azure Blob Storage, Amazon S3, and also use Fabric data pipelines or data flows. So overall, Eventhouse gives you a very flexible, high-speed platform for working with real-time data inside Microsoft Fabric. Next, let's talk about the strengths and weaknesses of this data store to better understand what is it good for and when you should consider another data store. Let's start with strengths. Eventhouse is optimized for real-time streaming and telemetry data ingestion. It is built to handle very high volumes of fast-moving data like logs, events, and sensor readings. It is designed for low latency analytics. This means that you can run queries and get fast results even when the data is constantly arriving. So if you have a case that needs some near real-time capabilities, then Eventhouse could be a great option for it. Also, Eventhouse is ideal for semi-structured or event-based data. For example, if you're working with JSON logs or IoT data, Eventhouse is a great choice. So data coming into Eventhouse doesn't have to be structured as in the warehouse, for example. Eventhouse is also highly scalable. It can handle millions of events per second without slowing down. Of course, this also requires a lot of Fabric capacity, but still it is doable with Eventhouse. Finally, Eventhouse supports real-time dashboards, anomaly detection, and operational monitoring. This makes it a strong platform for real-time decision-making and alerting if you are facing those kinds of challenges in your business or projects. Now let's talk about the weaknesses of Eventhouse. Eventhouse is not designed for traditional relational modeling. It is not optimized for classic star or snowflake schema models like for example warehouse that we covered in the previous episodes. Also, transaction support is limited compared to the relational engines like SQL databases. You will not get a strong ACID guarantees like you would do in a relational database. And this is not the data store for that kind of use. Short data retention is typical. Eventhouse is usually used for short-term, real-time analytics. It is not the best place to store multi-year historical archives. Soon we are going to talk about data retentions that are typically used with event houses and KQL databases, since in many cases we don't want to store years and years of telemetry data, for example. Also, with Eventhouse there is a limited support for complex multi-table joins. You can still join tables, but it is not as powerful or flexible as in relational database. And finally, like I already mentioned, to really unlock the power of Eventhouse, you need to master Custo Query Language or KQL. It is different from SQL, so there may be a learning curve for new users, even though it's not super difficult language to learn, especially if you already know SQL, since there is a lot of similarities and same type of logic applies to it. Let's now go through the key objects and concepts you will need to know inside event houses and KQL databases. First, we have query sets. A query set in Fabric is an item that organizes multiple saved KQL queries. It is quite similar to a notebook as an object. And when you create an event house, it automatically creates a KQL database and one query set to that database that you can then use to query data. Next, we have tables. Tables are the core storage units where the event data is ingested and queried. If you have worked with basically any database before, you should be very familiar with tables. The main difference here compared to traditional database tables is that KQL database tables are a bit more flexible with the data types and support some semi-structured data types as well, so your data doesn't need to be entirely flat. Then there are materialized views. These are pre-computed query results that can boost performance, especially when you're building dashboards and reports. We are going to discuss these in more detail shortly and also do a demo about them in the demo section of this video, since materialized views are an important part of DP-700. We also have functions. Functions are saved reusable pieces of KQL logic that can help you simplify complex queries. We will come back to functions in the demo section as well. Eventhouse and KQL database also support shortcuts. Shortcuts we have covered detail in the episode about Lakehouse, but basically they allow you to query data stored in OneLake or in external data stores without duplicating that data to Eventhouse. These shortcuts could be a great, for example, to some type of reference data that is needed with your event-based data. For example, a reference table about IoT devices that provides more information about those devices that are sending readings to Eventhouse. Next, let's talk about policies and start with retention policies. Retention policies control how long data is kept before it is automatically deleted, help managing storage costs, and keep Eventhouse focused on fresh data. Then we have caching policies that allow you to cache new data so that you can access it faster. However, this important query performance comes at the cost and it will increase the storage costs. So you should be mindful about how much data you really need to cache. Also, you can't have a caching policy that extends over the retention period, since that wouldn't make any sense. Finally, we have OneLake Availability. When enabled, OneLake Availability makes Eventhouse data accessible across Fabric services by exposing it as open Delta Parquet format. We're going to have a separate slide about this shortly. But here are the main building blocks you need to understand when working with event houses inside Microsoft Fabric. Of course, there are other concepts and objects as well, but these are the main ones you should know in the DP-700 exam and also in general. Now let's talk about materialized views inside Eventhouse. A materialized view is a way to store pre-computed query results as managed tables. This means that instead of running a heavy query every time, the system keeps the results ready for you. Here on the side we can see an example statement for creating a materialized view. We are going to break down the syntax shortly. Materialized views are great for improving performance, especially for dashboards and often run queries. They are ideal when you want to do aggregation, filtering, or light transformations on streaming data without overloading your database. There are two important properties to remember when creating a materialized view that are also being used in the example query. First, we have the backfill option that can be used to control do we want to have historical data in our materialized view, or do we want to just include the data that has arrived after we have made that view. Then we can use effective datetime property to determine how far back we want to backfill our view. Now let's break down the syntax a bit since we are going to have this example in the demo section shortly. If we start from the top, we say .create async materialized view, and that is the create sentence for creating these views and similar to create sentence in SQL. Defining that async there is optional, but it ensures that materialized view is created immediately even though the historical backfill would be still running and not done. So for example, if you have very large dataset, most of that dataset probably is not yet processed when you can already start to use the view. And if you would have a ton of historical data, the view creation could actually even time out if you're not using the async option. Next, we have those properties/options that we can specify for the view. Here I'm just using 3 properties, but there are a lot more that are out of the scope for this video. Those 2 we already covered, so we want to have a historical backfill for this view and starting from 1st of December 2024. Then that doc string can be used to add some documentation what this materialized view is about. Next, we have to specify a name for our view, and then we have to tell based on which table this materialized view is created on. And lastly, we specify the query that is being used to create the view. We're going to come back to this example very shortly in the demo section and actually use this exactly same query as part of the demo. Overall, materialized views are a powerful tool in your arsenal when you need fast real-time analytics based on fresh event data. Now let's talk about OneLake availability inside Eventhouse. By default, when you ingest data into Eventhouse, it is stored in a format that is optimized for very fast KQL querying. However, this default storage is not automatically accessible by other Fabric engines like Warehouse or Spark. And if you would like to query the data in an Eventhouse or a KQL database using, for example, a data pipeline or a notebook, it would have to use the KQL database engine for accessing the data, since it is not in a very native format, for example, for Spark to read. OneLake availability solves this problem. When you enable it, Eventhouse data is stored in OneLake as a Delta tables, which is an open and standardized format and very widely used in Fabric. You can enable OneLake availability either at the database level or at the individual table level. This gives you flexibility depending on your needs. Once enabled, your Eventhouse data becomes available across Fabric. You can query it using Power BI, Warehouse, Lakehouse, notebooks, and more, all without making copies or doing manual exports, since that replication is handled by Fabric on the background. The data retention policy that you defined inside Eventhouse is also applied to the Delta Lake file stored in OneLake. So if your table is set to automatically delete old data, the same rule is enforced in OneLake storage too. There are some important limitations you should be aware of. When OneLake availability is turned on, you cannot rename tables, alter schemas, apply row-level security, or delete, truncate, or purge data. If you'd like to do some of those operations, you would first have to disable the OneLake availability and then do them and then re-enable it. Overall, enabling OneLake availability makes Eventhouse much more powerful by opening your real-time data to the full Fabric ecosystem in a better and more native format. Next, let's go to Fabric and do a demo/tutorial about these topics that we just covered here. Before we open Fabric, I would like to know that I spent a ton of my free time creating these videos for you, and that's why I would like to hit that like button and subscribe to the channel for more DP-700 and Fabric content. This doesn't cost you anything, and I would highly appreciate that. Also, if you'd like to support the channel with a cup of coffee, you can do so by clicking the Buy Me a Coffee link that can be found in the description. But now, let's go to Fabric. Now we are in Fabric and I have my DP-700 tutorial workspace open. And as we can see, we already have one Eventhouse in this workspace that I created in the beginning of this series when we covered the introduction to the all things we are covering in this series about Fabric. And in that Eventhouse, we can see that we already have one KQL database there and also one query set. And those objects are created automatically when we create an Eventhouse. But yeah, let's open up this Eventhouse and let's check a few topics here about it. And here we can see the Eventhouse view here. And like I explained in that first section, Eventhouse is basically a container for KQL databases. So it acts as a folder or container, so Eventhouse itself doesn't really do that much things. So basically here we can just monitor and get this monitor view what's happening in those KQL databases that we have in our Eventhouse. And from this Eventhouse level, we can actually create more databases to this Eventhouse by clicking this plus database icon here. Then we also can monitor our databases that we have here. And here we can see that not much have been happening in this database that we have here since the last ingestion has happened in February, where we covered the real-time analytics and actually ingested some data to this KQL database here. And here also we can control the minimum consumption of our Eventhouse. This gives us some control over how much capacity our Eventhouse is actually consuming, but we are not going to change these here right now. So let's close that. Then we also have some Python plugins that can be used with the Eventhouse. And then we can also toggle and untoggle this Eventhouse details here. And here we can get, for example, the query URI or the ingestion URI for this Eventhouse if we would like to use those. But yeah, we are not going to utilize those in this demo. And here we also get some basic information about the Eventhouse, like the region it is located, and do we have those Python plugins installed or no. And now let's go to that KQL database and talk more about that. Let's open the only KQL database we have in this Eventhouse, and we can see that we have here already a bunch of tables that we have been adding here when we have been doing tutorials here in Fabric, like the introduction and also those ones where we wrote data here using event streams. And like said, event streams is only one possibility how you can get data to the KQL database. And here we have a bunch of different options. So for example, we can get some sample files from Microsoft or upload local files or get some data from our OneLake and then use that event stream option, or from Azure Blob Storage, Event Hub, Amazon S3, using a data pipeline, data flow, or real-time hub. So there are plenty of options how you can ingest the data into the Eventhouse. And then we have these possibilities to query our Eventhouse. We can use these KQL query sets, or we can use, for example, a notebook, or we can attach a real-time dashboard to this KQL database and use the Eventhouse that way. And next we have those data policies here that we already covered in the theory section, but here we can apply them. So we can set that retention period after which the data in our KQL database is actually deleted. Then we have this caching policy here, and basically we can use this to determine the time our data is in the hot cache, meaning that it is more readily available and stored in this very fast SSD. But this means that storing our data costs more. So even though it is faster, it is more costly. So you can specify here, for example, that you want to only have 5 days of data in that hot cache, and after that the data will be moved to that cold cache so that the querying it is slower, but it costs less to store it. Let's close this, and then we have the OneLake availability. Basically, this is the OneLake availability that allows us to set this OneLake availability on the database level. We can also configure this on the individual table level if we want. I'm not going to turn this on now on the database level, and we are actually going to turn it on table level shortly and see how that will behave. Next, let's talk about these different objects that we have in this database. First, we have the tables here, and of course, if you have been working with any database before, you basically know that in databases, data is stored to tables. Next, we have shortcuts here that we can use to bring in some external data or data from our OneLake to this Eventhouse without actually copying it here. And here we can create a new shortcut if we want, and we can choose, for example, our OneLake to be our source for that shortcut, or then we have some of these external sources like S3 buckets, Azure Blob Storages, Dataverse, or Google Cloud Storage. This would allow us to bring in some data to this Eventhouse. For example, we could have a reference table about our IoT devices that are sending data to this Eventhouse, and then use that reference data to enrich our data that is coming in from those IoT devices. But now we are not going to create any shortcuts to this Eventhouse. And next we have the materialized views that we are going to come back shortly, and also functions that we are going to cover shortly as well. But now let's try out that OneLake availability, and let's turn it on for this temperature data here. And here we can actually turn it on this table level, and let's click on, and now this data will be made available in OneLake. And now if we would go back to our workspace and we would, for example, open up our lake house and we would try to create a shortcut here, we should be able to shortcut that data. And we can create a shortcut to, for example, to this DBO schema. And let's create a new table shortcut. Let's choose Microsoft OneLake. And then we are going to select our KQL database and then click next. And here we can see that the only table that is available here is that one that we had now at OneLake Available. So we can only shortcut now the tables that we have made OneLake available. And since I have only made that table, it is the only one that we can use here. And also now when we have made that table OneLake Available, we could actually use it in a notebook in a very similar way we use lakehouse tables. We just have to define the path to that table in OneLake and then we can query it like we would query any other Delta table. Otherwise, if we would query these tables in the KQL database using notebooks, we would have to use the KQL endpoint and use the KQL engine to access those tables. But when we make them OneLake available, we can skip that KQL engine in between and query that in a more native way for Spark. Next, let's do a demo/tutorial together about materialized views and functions. And remember, if you would like to get this material and the code that I will be using in this demo, it can be found by clicking the link in the description. That will take you to the Google Drive where I have all the materials for this course. But yeah, I have this query set here, and in this query set I have two KQL queries. The one is empty, and in the other one we have the demo. So let's start with the demo. So we are going to create this table about the website visits. So we are going to have a visit ID, then we are going to have a visit timestamp, and then we're going to have the page that was visited. And now let's create this page and let's run this. And now the table has been created, and then we want to ingest some data to that table. And I'm using this KQL inline syntax to ingest some rows to that table. So we have few rows of data going to that table, and let's run that. And now let's query that table and let's see that we have those rows here. And now we can see that we have those website visits in that table. And next we are going to create a materialized view on top of that data. So first we are going to create a materialized view without backfill. So if you remember from the theory section, we would actually have to provide this backfill true if we want to backfill our materialized view. But in this first example, we are not going to do that, and we are just going to specify the document string for this and tell that this is daily website visits without backfill. And then we have this KQL query that will then define that. And we are going to name this materialized view as episode 15 MV daily visits no backfill. And this KQL query here actually groups by those website visits per day. So basically here we are creating a new column called visit day, and then we are going to use that visit day there to summarize the visit counts for that day. So we know how many website visits there were in total per day. So let's run this materialized view and let's create that. And now that has been created, and then we can query that. And as you can see, we don't have any data in that materialized view, and that is because we didn't specify any backfill for it. For now, if we would ingest in some new data, that will actually show up in the materialized view, but automatically we do not backfill that view with that old data that we already had there. And here we have the code that will actually backfill that materialized view with some old data. So here we are specifying that we have backfill true, and then as an example I'm also specifying this effective date time property here. And with this we can control how much history we want to that materialized view. So if we don't want entire historical data sets about that specific data that we are going to use for the materialized view, we can limit that using this effective date time here, so that we say that, for example, we want to backfill only last 3 months or so. But yeah, let's create that, and the query here is exactly the same that we had in the first case. So let's run this, and then let's query that materialized view, and let's see, do we have data. And now we actually have some data in our materialized view since we backfilled that, and we can see that we had there 2 visits on the first day, and then on the second day we only had 1, and then on the third day we had 2. And then as an extra command here, I'll just show all the materialized views that I have in this database. And here we can find some information about them and also see that document string there that tells more information about those materialized views. So it is good practice to always specify that doc string to let people know what your materialized view is all about. Next, let's ingest some new data into our table. So let's run this and let's ingest 2 new rows. And now let's query our original table again, and we can see that now we have more rows since we ingested a couple of more rows to that table. And then let's query our first materialized view that has not been backfilled. So we should only have data about these 2 rows that we have here. So let's run that. And we can see that for the 4th day, we have those 2 visit counts, and that's correct. Then let's check our other view that was backfilled, and we should have the old data and also this new data there. So let's run this query and we can see that we have the old data there and also that new data that we just added there. And this demonstrates you how the backfill functionality works, since this is an important topic in the DP-700 exam. So remember this. And next, let's do a quick demo about functions. And here I'm specifying this function, get daily visits per page, and then we have one parameter page name going to that function. And we are going to use that page name to filter our website visits per page. And then we are going to use the same logic we had in those materialized views and get views grouped by for that date. But now we are filtering that result per page. So before we do those summarizations, we are actually filtering the data for that specific page. But yeah, let's define that function here. And now we have defined that function, and we should also see the function here, and we can also see the materialized views here as well. And now we can use that function, and we can call that get daily visits per page, for example, to the home page. And we can run this query and order it by the visit day. So let's run this and let's see what is the result. And here we can see how many visits we had to the home page per day. And then we can run this function again for the blog page and see the similar result here, but now for the blog page. And we can see that we have only had 1 visit to the blog page. And that should be correct if we query our original data here. And we only have 1 visit to the blog page, and that was on the 3rd day. Next, let's have a couple of questions related to topics that we covered in this episode. But before we do that, I would like to tell you about this website called certiace.com that I have created with few friends that offers free custom-made practice questions to Microsoft certification exams like DP-700 and DP-600. And here, if we open up the DP-700, we can find questions per module here. So if we, for example, open the first module here, we start to get these example questions that we can use to practice to the DP-700 exam. And always when we answer to these questions, we get the explanation for the correct answer, and then we also get the related learning material that we can use also to check why the specific answer was correct. So after watching this video, go check out certiace.com. But now let's have those practice questions. Let's have our first question. Which of the following statements about backfill and async behavior in materialized views is true? A. Without async, creating a materialized view can fail or time out if backfilling a very large historical dataset. B. If backfill equals true, the materialized view can only include data ingested after the view creation time. C. When async is used, user must manually trigger the backfill process after view creation. D. Setting backfill equals false automatically applies a 7-day lookback window by default. Now think about the answer for a moment and pause the video. I will reveal the answer in 3, 2, 1. The correct answer is A. Since when not specifying async when creating materialized views, long backfills can cause creation to fail or time out because the system waits for full backfill to complete. B is incorrect since backfill equals true means that old historical data is included, not just the new data. C is incorrect since backfill starts automatically when async is used. No manual action is needed. D is incorrect since backfill equals false disables backfilling completely and no automatic lookback is applied. Let's have another question. Which of the following statements about enabling OneLake availability for an Eventhouse or KQL database is true? A. After enabling OneLake Availability, you can freely rename or truncate tables in the database, and then that is reflected in the OneLake. B. OneLake Availability allows data to be stored both in the Eventhouse internal storage and in OneLake as Delta Parquet format. C. OneLake Availability is enabled by default for all new Eventhouse databases. D. When OneLake Availability is enabled, only newly ingest data is stored in OneLake, and historical data export has to be triggered manually if needed. Now think about the answer for a moment and pause the video. I will reveal the answer in 3, 2, 1. The correct answer is B, since this is the behavior of OneLake Availability feature. A is incorrect, since you cannot do those operations once OneLake Availability is enabled, and you would have to turn it off if you want to do them. C is incorrect, since OneLake Availability is not enabled by default. D is incorrect, since historical data is automatically also exported to OneLake. And that is all that I wanted to cover here today. If you'd like to continue your learning journey towards getting that DP-700 badge, check out the next video in this series. And now I thank you for watching and see you in that video.